Okay, so let's start the unit number 5. Okay, principles of spectrums. So before taking up the unit number 5 as a spectrum, I would like to mention, okay, I would like to mention the very important point of view is that what we have studied so far in the unit 1 and unit 2. See, basically what is a communication system? The communication system is the one we are transferring the message from the transmitter to the receiver through channel. So whatever the signal we are going to send, absolutely from the transmitter, we are going to use the protective in the form, protective form. That is absolutely protective form. Okay, so okay, the protective form. Okay, the protective form. Okay, uh, exactly we're in the protective. Okay, okay, exactly. A protective form, we protect the messages in the form of the protective. Okay, so that means through a modulation techniques you're going to send. So how you're going to do that? We are protect the information from the transmitter to the receiver, absolutely in the form of the modulation techniques. Okay, exactly in the modulation techniques. Okay, through either one. That means whatever the signal, the information, by using a carrier wave, you convert into what exactly? A signal called as a modulated signal. In this modulated signal, there is an information content, what we call as a complex signal. In the first unit, we represent how exactly the complex signal will be there, how the signal will be represent, how the signal will be identification at the transmitter and the receiver of the complex signal, how we construct the signals, and how you at the end of the first chapter, you also told that how the information absolutely passing to the 1100 information in the form of the code, as we, since you're talking about digital communication. Basically minded digital communication, what you call, irrespective of the communication system, we have to send this communication, we have to send through a absolutely through a productive form in either communication part, that is analog communication or digital communication part of view. So we studied in come back to the second signal is in a come back to the second unit, what we call it as signal representations. What in this kind, how the exactly signal will be represented before sending, because of course we, as we mentioned in the first unit, that the signal will be sent in the form of the complex signals. That means absolutely it consists of a three signal. One is information, another one is what exactly carrier signal, which is used for protective, which is used for protecting the signal, or in whether the information will be kept in this carrier signal. When you multiply the information plus what I call it as the carrier signal, will get back a resultant signal, we call it as a modulated signals. Okay, absolutely. In the second, the signal representation, in the second chapter of signal representation, how exactly each signal will be sent. See, each signal will be sent irrespective of the communication system, will have each signal, will have some kind of a phase and frequency. That means whatever the information along with the phase will be converted. That is why we represent Si of j is equal to what? Integral minus integral 0 to t into Si. That's the information. 5 what we call orthonormal buses, which contain information in the phase and such. That means each signal we are going to send across to the from the transmitter to the receiver across the channel. Absolutely, it consists of this each function. We represent that how exactly each representation. Once this signal will pass on to this, because we told it very clearly, these are the kind of the signals will get affected in the AWG channel, because since we are restricted our discussion in the AWG channel, because since you are at the undergraduate level, and to understand that, to how the communication part, we are taking AWG channel. What is exactly AWG channel? It contains additive wide Gaussian noise. AWG channel is equal to additive wide Gaussian noise, which is having a noise constant. That means signal will pass through, which is multiplied some of the noises, but see, noise will not vary the frequency, because please mind it, irrespective of communication, whether it's analog or digital, we are going to send the information in the protective form, that is a modulated signal by using carrier. Okay, absolutely, with kind of a phase and frequencies. So that means when you say the noise does not vary the frequency and phases, will give the constant magnitude. That means if signal phase and frequency will not be changed. That means we can use one of the best ideas in AWG channel is when you protect this information to be sent to the transfer to the receiver in the form of the phase and the frequency, the information will be protected. It does not much changes because the magnitude of the noise get multiplied to the magnitude of the signal. Of course, I do agree magnitude of the signal get changed, but still the phase and frequency are quite very, very important because that is the one which affects the magnitude and response of the system. Because you know, when you take any kind of a system, whether a transmitter or receiver or any kind of a system, will take the response in the frequency domain, but the frequency domain with the help of the what you call it as a Fourier transform, which absolutely gives the magnitude of the signals. Okay, magnitude of the signal with the help of that. Okay, so that means absolutely that is why we use the AWG channel. So we represent how the signal. So exactly how exactly the signal will be. Once the signal is protected and it will be multiplied with the base function, taking over an integral of 0 to t, that is why s of z will transmit through the receiver through channel, this channel, okay, exactly through the channel. Once it receives the signal, okay, what we call it as observation sector. See, this observation vector, okay, exactly called as observation capital X at the receiver, it is demodulator. We are going to multiply it into the different basis function, which is as exactly same as the basis function which we multiply for each information at the transmitter. Once that two signal will be used, signal will be identified whether it is a one or two through the kind of a techniques. Generally, how the signal will be recognized by the receiver, it will plot in the LCD spaces. We can identify whether whether it is belong to the required these things. For example, if the sended signal, if the received signal, that is sended or received signal, which is false on the plus e to the power of AB, that means it is the signal, whatever the signal received is 1 bit. So the form of the digital signal. That means absolutely we identify the LCD technical, then the signal goes. That is absolutely we learned about in the second chapter. When you come back to the third chapter, what we are told that absolutely, because since very important the digital communication point of view is that absolutely your digital communication point of view or any communication point of view, we have to protect the information. Because why we are not to protect the system? When the information is passing to the channel, it will affected by 3 parameters, which is clearly told. Number 1, absolutely because channel noise. Because channel noise is absolutely some of the signal absolutely present exactly in the signal itself, in the channel itself. But is that means because some of the signal due to interference. Let me come back to some of the signal which is present due to internal factors. Let me not talk about some signal will get interfered with information and information will be spoiled. That means degradation of the signal, that is the information will lost. One of the factors. The second factor is really affecting the communication is that what we call it as signal parameter, where signal parameter randomness. That means signal will contain information that is frequency and in phases of this. Okay, as the signal passing through this kind of a channel, let me say AWG channel, the signal frequency and phase parameter value depending upon the channel condition, characteristics, what we call as characteristics and channel medium, all this thing. This is the one of the factor, especially the phase is a very critical. As the signal is passing through the channel, the phase of the signal will get changed. Third point of phase, the signal get in the channel. Third point, absolutely we're talking about it. Third point is a third point, we are talking about what you call it as third point, we are talking about it, the signal. Third point we're talking about it. The third point is transmission media of the channel. Okay, absolutely. Please try to understand. The transmission media has some kind of characteristics. What kind of material, what kind of techniques you are used to manufacture that channel. That's all important matters. These are the 3 factors which absolutely overcome by the switch. Okay, that is absolutely we deal with in it. Modulation techniques, all kind of the whatever the noise likely to be interfered in the channel will get over through modulation techniques. Since we are talking about digital modulation techniques, there are 3 types of modulation techniques absolutely used. Number 1, what we call as BPSK, that is binary phase. There are 3: ASK, PSK, FSK. ASK is called as amplitude shifting key. Third is called as a binary phase key. Fourth is exactly called frequency shift key. See, these all are very important. ASK, amplitude shift key, which this we call as on and key, on or of keying method of shifting, on or key that, which is this is only we are passing the information wherever the amplitude is 1, wherever the amplitude is negative, we don't pass. That is why this much is not used, because when we are discussed very much absolutely in the third chapter, where exactly BPSK, that binary shift key. Here what will happen here, importantly, please make note, all the information, let us say 110, will be put in one carrier way, only one carrier way. In this carrier, we are going to change the phases of the signal as the signal symbol get changed. Symbol means information, that is one. As the symbol of the, if the frequency of the signal get one changes, and the frequency of other one, for one frequency, let us say phi of 1 2 and omega c phi of 1, and if the phase of the other signal is get changed, what we call phi 2. Okay, so likewise within the one carrier, if the one carrier signal within one carrier, what we call frequency of the signal is get, frequency of the phases of the signal is get changed. That is exactly called phase frequency. And we are talking about what is kind of an equation, how exactly the equation will be generated, and deduction will be taking place in the third chapters. Okay, absolutely, we are talking about furthers. Likewise, we are conclude the BPSK and the FFSK likewise. But please mind it here, very important, please keep in mind, in digital communication, even though information that is in the form of 1 and 0 will be converted to binary sequence by pulses to any kind of the, what we call it as line coding techniques. From this line coding techniques, we use the carrier waves, we put across this binary sequence, that is an information within the carrier of sinusoidal cosine signal. That means even though we are information sending, it's a digital, but ultimately we are sending from the transmitter through the channel to the receiver via in analog form. Please mind it lovely of the digital communication, where exactly we retrieve the information at the, we retrieve the information at the receiver in the form of the digital signal. So that means whatever the channel, even the digital communication, the information we want to send across to it in analog communication. Likewise, we talked about FSK, PSK, how the each QPSK, what is exactly the QPSK? Quadrature generation, that we have discussed very BPSK, FSK, BPSK, and QPSK, MRA, MCAM. We could understand what all the kind of this, how this generation takes place, what kind of an advantage and disadvantage. When you come back to the fourth chapter, what we talked about, band limited channel, where in the band limited channel we talked about, the channel is limited by itself because of the, it allows a certain frequency and the frequency of the signal to be transmitted and reject otherwise. The function is same as that of the what linear filter. In the band limited channel of the unit 4, what we talked about is exactly that is, okay, how this the behavior and model of the channel can be viewed as the performance of the linear filter, because linear filter is the one which allows the design. We designed that linear filter with the help of the basic elements of the electronic devices, where it can reject some certain part of the, where it can reject the some frequency and allow the frequency, what allow frequency we call as a desired frequency, the function and performance characteristics, which is same as the channel, which is accept some kind, that such kind of a channel we call as a band limited channel. We come across how the linear, how we equated in the fourth chapter, absolutely, how this the channel can be equated as a linear filter model, and all these factors we discussed very thoroughly. Now let's come back to this principle of spectrum, the Modulo-5. The principle of the Modulo spectrum is very important here. See what exactly this principles of spectrum uses. Okay, this Modulo-5 talks the principle of spectrum. Let's go back. What is exactly the split spectrum? Look back, today's scenario is the one, it is not just communication. Let's keep in mind of the three factors in this. One is today's scenario is absolutely talks about electronics, rate of transmission. That means we are transmitting the message with high frequency. Second is utilization of the bandwidth, and third is less using the transmitted power. There are three coins. Of course, let me talk about electronic device. Apart from this, when you look, by leaving this communication system, when you look at the macro levels as electronic device, apart from three, the size, and that is fourth, that is the fifth is cost. Today, what we talked about is absolutely utilization of the bandwidth. When you come into the communication system, is absolutely using the less transmit power, using the high rate of transmitter. That means you utilize the efficient utilization of the bandwidth is most important. Less use of power to transmit high data rate. Okay, that is why these are the two factors absolutely keeps in mind. See, look back, let's come back to that. What is, let us say, channel? We have some communication channel. In this exactly the communication channel, let us say we are going to send one signal, let us say with a frequency f. If I pause the signal, the frequency of the signal, if I pass it to the channel, okay, exactly, okay, it uses the, let us assume that it uses some part of the channel itself. That means other part of the channel is get waste. If you say other part is not using other kind of allowable frequency of the channel, we are not used it. That means it's not efficient utilize of the channel. Indirectly, you can say, if you not use the channel, or if you not use the channel for transmitting over the area of the channel for transmitting, that means you're not allowing what I call it as the not utilizing the required bandwidth. When it is allowable, when there is a space to space, you're not using, that means absolutely utilize. So here in this model of I, we talked about how exactly uses of this, what I call it as, it's called how exactly we're going to use multiple signals in the channel. That is exactly called spread spectrum channel. Spread means what exactly? We're spreading the more information, more different information at the modulator, that is a transmitter input. From there, we spread so many information in where I call it conglomerate to each other. We're going to send with a technology called TDM or FTM, that is time division multiplexer, frequency division multiplexer. That absolutely the signal flow across the channel. Okay, all the signals will flow at a multiple, at the same time, or otherwise we can say at a different instant of a time, so that the signal will not get interfered. Of course, let me frankly admit, there are interfaces, there are, because none of the channel, irrespective of what kind of a media is, and today with what kind of a frequency you, if the channel will have kind of a what we call as an unwanted signal, unintended signal through ISI. That is exactly intersymbol interferences, additive channelized, and of course signal parameters, and of course what we call it extra factors. These are the factors which are considered. But ultimately, the division, ultimately the successful communication is the one who can able to design the system as less possible with the noise interferences and process signal with the maximum efficiency. That's absolutely consideration. Of course, with utilization of the bandwidth of utilization, less transmit power, high data rate frequency, less what you call less area, less cost. That is most important as on today electronics. Okay, so this is exactly I'm going to send you given clear introduction spread spectrum. You can look back here. Spread spectrum is absolutely here. The main object of the digital communication system over AW channel is the efficient utilization of transmit power and channel bandwidth. I mentioned that this is only particular digital communication. High data rate means you have to send the information with high number of SCs, information processing is much at number of per second is much higher. If you say number of information per second is moving across the channel, it means that we are sending the information is because information containing signal is in the form of hertz. Absolutely, we can sending the information, but more information has been done. That means if you increase the high data rate of application, that means high number of cycle per second, that is number of hertz is increasing, more information is called what we call high data rate application. So utilize your bandwidth, of course. So look back, when you unit is of course fine, we are going to send the, we increase it more number of number of cycle per second increasing, but you know, you have to send the signal through a power is required. If you increase the more data rate, more number of cycle per second, then it requires more power, that means more transmitted power. Very important, if you use more transmit power, cost is high. Okay, exactly, cost is high. Okay, cost is high. Okay, exactly. Okay, exactly, the cost is high. Okay, cost is exactly, the cost is high, right? The cost is, okay, cost is high. So what we are going to use is transmit power channel bandwidth. Okay, so that means transmit power channel bandwidth will be utilized. That means the cost is high, and also when you use a more transmitter, that means dissipation power is lost. That means unnecessary use of a power loss, which may be what we call it as which may heat up the systems, either at the transmitter or at the receiver or in the channel itself. That means signal might get changed. That means we have to trade between the utilization of the bandwidth along with what exactly the transmitted powers. Okay, that means how much you want to use the transmitter power, how much bandwidth you have to use, that is exactly the bandwidth, so that you can utilize. That is exactly the real intelligence of the communication system. Use this exactly. The channel coding, okay, exactly. What is exactly the channel coding? Allows to raise the transmitted power by increasing the transmitted signal. Okay, so allows the transmitted power, allows to reduce the transmitted power by increasing the transmitted signal between the through coding and redundancy. That means it reduces the transmitter. This is channel code. What we mentioned, the digital communication system, we understand that. First is exactly we are going to use, okay, that is the information. From their information, with this binary coding, from their binary coding, you are going to use what you call it as the coding of the channel. We convert the information of the binary coding into some other form. It may increase the transmit, it may increase the bandwidth and also lesser use of. That is exactly called coding redundancy. What is exactly code redundancy? We rearrange the code such that less transmitted power will be utilized, but with utilization bandwidth, of course, with high turnover application. Such we call it as through code redundancy. That means we are going to reduce the unnecessary codes, unnecessary avoiding of this will happen. So code rise the trade of a transmitted power with the channel. Now exactly R is equal to information bit rate at the input to the transmitter. R is equal to what exactly? So now let us say that means R is equal to information rate at the transmitter level. W is equal to channel bit. Now let us introduce one more important thing is B is equal to W by R, bandwidth expansion factor of the channel. Okay, coded transmitted signal. That is equation number 1. So now, so that is, let us say, that is a channel is a information, that is a bit rate, that means number of cycle per second transmitted. W is equal to what? Width of the channel, that is channel bandwidth, that is F2 minus F1 of that. So that is what we call one more factor we are introducing here called as BE. We call it as bandwidth expansion factor of the channel coded to coded transmitted signal to coded transmitted signals. Okay, so that means here, look back here. So that means bandwidth expansion. Basically what we are in this case, this is exactly the channel. In this channel, we have to use this. Maybe some of the signal I can pass it or some other signal also pass it. How exactly we're going to use efficient utilize of the bandwidth? That is exactly bandwidth. So that means look back here. So that means B can utilize for trade-off between width and transmitted power. So this will determine how best we are using the transmitter, the channel, how best we are using the rate of the information has been transferred. Okay. So if you look back by this equation, if width is increasing, rate of expansion factors also increases. Okay, expansion, bandwidth expansion. That means width is increasing. That means bandwidth of the channel is also increasing. If you decrease the what you call it, if you decrease the transmitted power, bandwidth expansion, that means increase, in order to reduce the transmission power, we need to increase the what? Bandwidth expansion. Okay, okay, exactly, please mind it. As per the equation, the band B can be utilized for a power and bandwidth code redundancy by increasing the bandwidth W, and hence B increases, thereby decreasing the transmitted power. Okay, so by increasing the transmitted, by increasing the bandwidth W, and hence B increases. So therefore we can say this, we can trade off this. This is what exactly spread spectrum. Let's come back to this. So that means so generally the B, that is bandwidth expansion will be ranged for 2 less than or equal to 5. That means B is equal to W by, or should be less than or equal to what? BE. That means 2 is the minimum, 5 is the maximum, so that we can utilize the bandwidth efficient. That means width of the bandwidth, what is exactly the bandwidth expansion for the channel is that. So that bandwidth utilization using the full channel, absolutely sending full complete. In informal, I can say, in practice, technically, I can say that utilization of the frequency, allowable frequency of the bandwidth utilization, that exactly we call it the bandwidth channels. Okay, so this is one factor. This is absolutely today you are using for AWJ channel since we are consideration. So let's come back today. So that means how we are going to utilize the full bandwidth, that is by using what exactly? B, W by R. R is transmitted rate of the input to be transmitted, and W is equal to exactly what? Width of the bandwidth channels. Okay. So now let's come back to the multiple access communication. So there are, apart from this B, that today the scenario, there are a factor which influence the bandwidth. Okay, so there are factors. That is, one is exactly a multiple access system here. So today, what I told you, there are, I mentioned it at the very beginning of this chapter. This is the, see, since so some of the frequency, some of the signal transmitting frequency very lesser than the allowable frequency of the channel. If I send alone the same frequency, same kind of a signal along the channel, some unutilization of the bandwidth of the, so that is allowable frequency. What we need, along with the same signal, we are going to send some other user can utilize the same channels in order to send that. That means we can say two different information used by two different users will be used for sending that information. We call it as multiple access communication systems. Okay, exactly. So multiple access communication system is that using the same channel by a different user with a different frequency at the same time, we call it as a multiple accession system. That means in these cases, we have to use again, okay, we have to use the channel. That is absolutely how much bandwidth of that. That means absolutely in the multiplication, what we call it as, what you call as a bandwidth W bar should be a greater than for. That means that is how best you're using the bandwidth. That is exactly W by R. That is bandwidth absolutely concerned with. Okay, exactly. Okay, exactly. This is the bandwidth is equal to W by R greater than 1. That means in order to utilize this multi-communication system, absolutely you are sending so much information at one channel level. It means that, okay, it means that absolutely the signal flowing through that, you are going to utilize the bandwidth channel in an efficient manner. That means for which bandwidth is equal to W by R greater than 1, it is greater than 1. This signal at the transmit, that means if you use W for in order to multi-communication system, the bandwidth W by R should be greater than 1. Okay, exactly. The second very important, second is very important. Okay, exactly. Second is very important. The second is very important fact that this kind of this we call it as spread spectrum of the signal. Okay. The second most important here, what we call it as, what we call randomness, pseudo randomness. What is exactly pseudo randomness? Because look back here, when you modulate productive at the input of this thing, when you use a multiple communication system, there are a lot of signals which absolutely at the input of the model. Once these signals, because as is told, that multiple communication system is the one, we are sending the different information by different users in the same channel, alloy at the same time with a different frequency without interference. That's what we call communication system. For the requirement, absolutely we call it as bandwidth expansion factor, that is W by R should be greater than 1. When you use this, that is absolutely, we are allowing multiple access communication system. It's only for what it exactly, it's only for what, greater than when you use the bandwidth of the channel efficient utilization with condition that, for which condition that W by R is greater than 1. Okay, exactly. So that means that is exactly, we call it a spread spectrum. We are spreading the different signals where at the input of the transmitter, that is input of the what, at the input of the what exactly, the signal of the channel which flows through in order to use the efficient utilize of the bandwidth, and also to use the what, less transmit powers, which we call the spread. Spread means all the signal will get, that all the signal is spreading across the inside the channel, we call it as. But of course, without very consideration, once you spread, there will be a kind of what I call interferences. That interference, it's a different tackle issues. Okay, how you're going to tackle, very shortly it comes the effect of you. So apart from this spread signal, another most important another term called a pseudo randomness. What is exactly the pseudo randomness? Look back here. There are a lot of signals which is to be flow along the channel, which is at the transmitter input of the modulator, because this modulator will protect this information at a different angle. So that means when you pass the signal, there are a kind of what we call it as some noise kind of a signal will be added in the transmitter, in the modulator itself, because of this some action process takes place at the modulator in order to convert that information into a productive nature, then sending across the same information absolutely along the channel. So this along the channel, what will happen, some of these noises will be introduced, absolutely, which I mentioned it because of so many other factors. That means unwanted information apart from the intended, that is required information available at the what, at the receiver, which may be due to the what, random factor which is expected to rise in the the channel, these random factors are absolutely called as what we call it as noise. Okay, so how exactly that means at the receiver we need to protect this kind of a signal. Okay, we need to retrieve, protect these signals, and retrieve the information at the kind of a receiver. We call it as pseudo randomness techniques. What exactly pseudo random techniques here, please mind it, we use some kind of a signal, what we call pseudo randomness, that is PR, or pseudo noises, PN. Okay, these two signals will be generated at the receiver, either one. This is absolutely same name, not either one plus. Sorry, same signal, that is PR or a PN, will be generated at the receiver for retrieving the information which are transmitted to the transmitter, but they got disturbed, distorted, redegradation of the signal because of the so many factors, maybe interferences, because interference meter, because so many signals are flowing in the multi-communication system, or it may be channel noise, or it may be signal parameters, the different signals are getting changed, or due to the transmitted power of the channels. So that how exactly we're going to use with called as pseudo randomness. Please mind, PR or PN or what are the pseudo randomness is a factor which is absolutely disturbing the signal while flowing through the channel, or even at the input of the modulator of the transmitter, which once it flows, that means this information at the received signal will have a unwanted information, what we call it as a noise. Okay, maybe due to what interference of the signal, because we are using a multi communication system, or secondly due to the channel noise, due to the external internal factor, or due to the what exactly signal random parameters, or maybe extra parameters like this. So this is how this is called as pseudo random. This is because some kind of randomness is taken. How we are going to tackle this kind of pseudo randomness or pseudo noise at this receiver, we have to do it. That means this signal, this has to be followed. Okay, so that means what is a spread spectrum? Spread spectrum is the one, absolutely. We are going to transmit the signal, different signal by different user with a different frequency. At the same time, we call it as a spread spectrum. We're spreading the different information at the input of the channel, so that the information will flow across the channel, so that utilization of the bandwidth of the channel is most, and hence we are going to use what we call less transmitted as per the bandwidth transfer, the expansion factor B is equal to W by R. Okay, that is exactly greater than 1 with this is. One more important point is here in this split spectrum, what we call pseudo randomness, because as we expected, so this signal will get will get degradation, or will get deteriorated in the channel because of the channel. So many factors which I mentioned, 1, 2, 3, 4 pointer in the channel, or it may some little extent at the input of the model there is a last block of the transmitters. So that means in the spread this is exactly pseudo randomness. Now let us take what we call it as an important block, what we call as model of this spread spectrum digital communication system. See how exactly spread communication and the digital communication text. This is exactly we call it a model of spread spectrum digital. What is exactly the basic elements of the spread spectrum signals? Look back. As usual, spread spectrum basic model will consist of channel decoder, modulator. Pseudo randomness is absolutely important. This pseudo randomness is, we can think of the carrier wave. This carrier wave will be put it across here along with the information. Then this information will go channel and demodulator. Yes, exactly in the demodulator, the pseudo the channel decoder takes place here. All what is a function channel will have some impulse responses CF, that means information will be converted into impulse responses. See, this modulator will take pseudo, that means this pseudo signal will be generated here, so that exactly with a great with a high enough along with the information, that means pseudo randomness will be in the will protect the information here. Absolutely, when you compare with this information, so generation of the PN junction will go, this PN sequences, randomness is generated, this information, okay, the transmission start in the simultaneously add this demodulator here. This is absolutely the receiver. As you know, once this receiver comes here, once the transmitter and in synchronize with this, what we call it as PN sequence will be generated to identify this what you call it as speed. This is the pseudo. Look back here, pseudo PN or PR is quite responsible to spread the signal of the different channels. That means this is the PN junction will generate with a different bandwidth and different transmitter powers. Okay, exactly across the channel. Where exactly in the demodulated point of view, okay, exactly, pseudo randomness patterns here which will despread, that means identify the different signal. This PN junction, PN, that is PR, pattern sequence generator, will absolutely despread the signal which is received from the channel with the help of the techniques. This, look back here, the PN here will be generated, that is called binary valued function, in which the information will be contained as the PN junction, PN sequence generated, this binary valued across the channels here. Once this exactly the channel passed here, automatically is received by the time this PN sequence generated in synchronous with the PN sequence of the transmitter, so that this will be identified. That means a despread, that means different informations, because since we are using the multiple communication system, we are going to use the multiple information at the channel. This information will be different information will be identified, which we call technically we call despread. This PN junction here, this PN junction, the transmitter will help you out for the spreading of the information. Where exactly this absolutely this pseudo pattern, another one is exactly pseudo pattern is exactly here, pseudo pattern. Okay, this pseudo pattern of general sequence at the receiver will responsible despread and channel decoder. That is exactly the basic element. You know what is channel decoder, what is modulator, pseudo. Here is the only thing is pseudo. This pseudo will help you to spread across. That means PN pseudo noise sequence generated, that is a binary valued, in which the informations or different information will be spread across the channel, and then once the PN junction, this will move across this channel and is in simultaneously synchronous this PN junction at the receiver, that is PN random what I call sequence generated binary value will identify the different these things, and it is responsible for what exactly despreading of the information. This info once the demodeler will identify the different information deducted, that the channel decoder will take off. This is exactly called a model of spreading of the digital communication system. What kind of a modulation techniques is used? It may be BEPSK, it may be FSK, it may be all the things as all be there. There are a kind of course, what kind of a possible interference is this? This is a two things. One is broadband, two when it comes, as I tell you, there is an interference of the, because since in the multi-communication spread spectrum, we use the channel with a different frequency and different these things. Absolute. So there are two kind of interferences will occur at the channel. That is, one is exactly called broadband, second is exactly called narrowband. What is exactly the broadband? The broadband is the one where exactly the broadband is the response when you use the multiple signal with high signal with a broadband wave, it is called broadband interference. When you use a narrow band is something limited of the frequency, some certain extent we call it as a narrow band. So this is exactly model of the, this is everything is same, and except the here one important is PN sequence, and that pseudo noise, pseudo signal generated for spreading, that is different information along the channel with help of the model, as simple as analog communication, absolutely what they call as a carrier way here, PN junction in the digital communication. This is binary sequence. Okay, so this is absolutely or as model of the spread spectrum digital communication. So let's continue the tomorrow classes. Thank you.